Hi, it's Mr. Anderson, and this is AP Physics Essentials, video 71. It's on electromagnetic induction, which is the ability of a magnetic field to create current inside a conductor. Now, scientists like Hans Christian Ørsted had already shown that if you have current in a wire like this, it creates a magnetic field, and that magnetic field could affect this compass needle, which is really a small little magnet. And so current can produce magnetic fields. But what scientists like Michael Faraday wondered is, could you take a magnetic field and produce current from it? In other words, was the opposite true? And this is the apparatus that he used to study that. And so we basically have two parts. We have a ring of iron, but on the left side, we have an electromagnet. So you're going to connect this to a battery, and that's going to produce magnetic fields over on the left side. And so the hope is on the right side, that could produce current inside this wire, and then we'd be able to measure that using a galvanometer. And so he set it up like this, and then he closed the switch. And so watch what happens to the current in the wire on the right side as I close that switch. And you can see that we generate a little bit of current, but then it goes away. And this is puzzling. So he opened up the switch, and watch what happened. We have a little bit more current, but it's in the opposite direction. So let me kind of close that switch, and we have a little bit of current, but it goes away. And then we open the switch and we have a little bit of current, but it's going in the other direction. And so that's electromagnetic induction. But what he wondered is, why is it only occurring right when I close the switch? So to understand that, you really have to understand the specifics of electromagnetic induction. And to understand that, you have to understand what magnetic flux is. Magnetic flux is how a conducting material, or any material for that matter, is affected by a magnetic field. And so what would be something similar? It'd be how you, or any material on our planet, is affected by light from the sun. And so it's going to be the amount of light from the sun, but it's also going to be the angle at which that light hits. And so magnetic flux is going to be the product of the strength of the magnetic field, how much or how large that magnetic field is, and then we're going to multiply that times the surface area perpendicular to that magnetic field. And so imagine that this right down here is a wire loop, and so we've got a little bit of a wire, and then we've got a magnetic field. And so if we ever have change in that magnetic flux, then we're going to have electromagnetic induction occurring. And so what happened right when he closed that circuit? Well, the magnetic field before he closed the circuit was 0, but then he added this magnetic field. So was there change in magnetic flux? Yes. And so was there electromagnetic induction? Yes. So it created current. What would happen if we were to increase the magnetic field? So let's double the magnetic field. Well, for a moment, as we're doubling the electromagnetic field, are we getting a change in the magnetic flux? Yes. Are we getting induction? Yes. And therefore, we're going to have current in that wire. And so by varying the amount of that magnetic field, we can get induction, or we can get current in that wire. Now, what's another way we could go at that? Again, we could look at the surface area that we're impacting. And so if you think of this as a wire, all of these magnetic field lines are perpendicular to this wire, and so we're going to have a large magnetic flux. But watch what happens when I turn it at an angle. And a good way to do this is simply count the lines of the magnetic field that it's hitting. You can see there's a reduction. And so the number of lines is different, but also these are not hitting it straight on. It's not perpendicular. So we'd have to use a little bit of trigonometry to figure out what component of that magnetic field is actually perpendicular to the surface area. But did it change between those two rotations? Yes. And so was there electromagnetic induction? Yes. And so there'd be current as well. And so let's say we turn it like this. The magnetic flux is going to be 0 because none of these magnetic field lines are going to be perpendicular to the surface. But it changed between those 2 points. And so we're going to have induction and we're going to have current. So that seems a little non-intuitive, but it has real world applications. And so the electricity that you're using right now and the microphone that I'm using right now as well use this idea of electromagnetic induction. And a great way to look at that would just be looking through a generator. And so how does a generator work? Well, in a magnetic field, what we can do is we can take these wires and we can start to rotate them. And as we rotate them, we're getting huge changes in magnetic flux. And so we're going to have huge changes in the current itself. And so if we look at the equation, magnetic flux, or phi sub B, is going to be a product of the magnetic field, how big that magnetic field is, times the cross-sectional area perpendicular to that magnetic field. And so if I take this wire right here and I compare it to this wire right here, which one is going to have a larger magnetic flux? It's going to be the one on the left. And the reason why is we're going to have more of those magnetic field lines go through it. What's a good way that we could increase magnetic flux is we could just wrap that wire a bunch. And so each of those wires, we're going to have the magnetic flux of that individual wire. And so by changing the magnetic field or by changing the size of that area, we can change magnetic flux. But also remember, we could angle it. And so if I angle it like this, we're going to have fewer of those magnetic field lines go through it. And so we're going to get a change in the magnetic flux. And here we would have actually no magnetic flux. But it's not a measure of magnetic flux that's important in producing current. It's, are we getting changes over time? And so this is a PHET simulation that gets at that. And so we've got a magnet over on the left side, and then on the right side we've simply got a wire hooked up to a galvanometer, or it's a voltmeter. It's going to measure the amount of voltage. And you can see that there's no current right now, but as I start to change that position of the magnet, I'm starting to get current. And you can even see the electrons moving in the wire. And so if I increase the number of wires, I can increase how much I'm deflecting that needle, how much current I'm actually moving inside the wire itself. Why is that? Now the magnetic field lines, you can see the magnetic field lines are changing. And as they change, we're getting change in magnetic flux. And so we're getting current inside the wire. Now another way to look at this would be through a generator. And so in this setup, what I have is a magnet down here on a wheel so that I can spin that magnet. I have my wire again, and I'm trying to induce current inside that wire, and then I'm going to measure the amount that I'm going to change. And so watch what happens now when I start to turn on the water inside that faucet. It's changing the position of the magnet. As it changes the position of the magnet, it changes the magnetic field. You can see the magnetic field lines are changing, and so I'm starting to get a little bit of current. What happens if I increase the speed of that water? I'm getting more current. We could even have a light bulb connected to it. And so now I'm starting to get usable energy. Watch what happens as I increase the number of wires. I even have more energy coming out. And now if I increase the water again, I even have more energy being produced. And so we're taking that energy of the flow of the water and actually making electromagnetic energy out of it. And so this is how the generators in a dam would work. We have the water flowing down through the dam. It's spinning these magnets, and it's creating that electricity. And so did you learn to construct an explanation for how a simple electromagnetic device like a generator works? I hope so, and I hope that was helpful.